Hi, everyone. Joining me today is Dr. Marwa Zatari, partner at Design Partners and Christian Weeks, CEO of enVerid Systems. Welcome to Healthy Air, both of you.
Thank you.
Thanks, Eric. Great to be here.
So I'd like to share Marwa and Christian's background briefly to provide context for our conversation. Dr. Marwa Zatari is partner at Design Partners and co-chair of enVerid Systems Advisory Board. She leads the research and development of air as a service around heat exchanger coils, ventilation, filtration, and indoor air quality measurements. Her work continues to advance building science methods in assessing performance-based procedures to design and operate buildings to optimize energy and people efficiency. Dr. Zatari earned a PhD in architectural and environmental engineering from the University of Texas at Austin, with a focus on the built environment, and a master's degree in engineering management from the American University of Beirut, Lebanon, with a focus on energy management. Dr. Zatari is a board member at the U.S. Green Buildings Council and is an ASHRAE distinguished lecturer and member of several ASHRAE committees, a member of the ASHRAE Epidemic Task Force, and voting member of Standard 62.1. Christian Weeks is the CEO of enVerid Systems, a leader in indoor air quality and energy efficiency. Christian has over a decade of experience in energy efficiency and indoor air quality and is passionate about helping buildings achieve their energy efficiency and indoor air quality goals through smart investments in HVAC systems and proven air cleaning technologies. Prior to enVerid, Christian was an executive with Enernoc, a leader in demand response in commercial and industrial energy efficiency solutions, which was acquired by NLX, and a management consulting with Deloitte Consulting. Christian lives in Boston and is a graduate of Dartmouth College and the Harvard Business School. All right, great. So excited to have both of you on. And really the driver of this discussion, or the motivation, is the big paper and initiative that you launched in August of this year. You released with several leading indoor air quality technology companies a white paper titled "How to Achieve Sustainable Indoor Air Quality, a Roadmap to Simultaneously Improving Indoor Air Quality and Meeting Building Decarbonization and Climate Resiliency Goals." Why did you write the paper, and who is the intended audience?
Thanks, Eric. So we wrote the paper to capture some really important lessons that we collectively learned from our experience during the COVID-19 pandemic that provide a pathway to achieve two important goals for building owners and operators. On the one hand, better indoor air quality, and the other hand, lower carbon emissions. The reality is that the way we improve indoor air quality in most commercial buildings today is incompatible with building decarbonization goals, because we improve indoor air quality today primarily by increasing ventilation rates to more frequently refresh indoor air with outside air. But in most climate zones, conditioning more outside air ventilation increases energy use and carbon emissions. So the pandemic taught us that there are ways to combine cost-effective air cleaning technologies with optimized ventilation rates to achieve energy and indoor air quality goals. And really, that's what we wanted to cement and demonstrate in the paper, with a strong reliance on the latest science on indoor air quality, and highlight the newest technologies to achieve these dual goals of indoor air quality and energy efficiency. So we've developed this paper really with a view towards as a practical guide that can help the people who own buildings, who design buildings, who operate buildings, and the key indoor air quality and energy efficiency stakeholders who support them. The paper is really for them to lay out a roadmap with concrete steps and recommendations to achieve these dual goals of indoor air quality and energy efficiency.
Excellent. So enVerid was the lead author of the paper, and then Dr. Zatari also advised amongst many other top experts. But you also co-authored the paper with 6 other companies and collaborated on the paper. Who else collaborated, and how did that collaboration come about?
Yeah, part of the most fun about this project was really the collaboration with people like Marwa and other experts we consulted, as well as with these other companies. The collaborations came about because we started looking around us to find complementary technologies that could help us deliver a system-wide solution to achieve better air quality more efficiently. And we also wanted to be able to validate and optimize the results that we were achieving. in our designs. So we started looking at other ways to make efficient ventilation, improve the ventilation efficiency, and we found companies like Auction8. And Auction8 specifically, joined us to collaborate on this paper. We were looking at ways to clean indoor airs of pathogens that would be complementary to what we're doing at enVerid on the gaseous contaminant side, and learned about companies actually through an introduction by Marwa, like Plan LED, which is in the upper room UV air disinfection space. So they became a collaborator for us. Erik, you and I have been talking for a while as we were exploring ways to prove that the engineering controls that were being installed in buildings were actually doing their job to remove pathogens and keeping people safe. And so we invited you to be part of this, and we're thrilled that you joined us in this project. IAQ monitoring was a really important part of this, total solution as well. So we learned about Reset, which is a global standard for indoor air quality monitoring developed by Giga. They joined us in the project along with Aware, which is a leading indoor air quality monitoring company. And then the last piece was around the controls piece. How do we make sure that we're able to optimize and automate a lot of what we're recommending here? And that's where we found 75F, which is built an IoT-based building control system. So the collaboration really came about by looking for partners who are helping solve a similar problem, but with different pieces of the total puzzle that we needed. And that's what drove the collaboration and made this such a fun project.
Excellent. Well, as you touched on in your first response, a key theme in the paper is the idea of cleaning indoor air rather than simply increasing ventilation rates, which is in contrast to the initial ASHRAE guidance at the start of the pandemic, and not just ASHRAE, but many other official bodies. Let's talk about how the ASHRAE guidance for COVID evolved and informed the framework laid out in the paper.
Yeah, as you said, Erik, so ASHRAE, Epidemic Task Force, and other organizations adopted the precautionary principle. So it was, do a lot from everything. And that meant the guidance was involved around, maximizing outdoor air, maybe up to 100%, and improving filtration efficiency, maybe, more than MERV 13, MERV 16, or even HEPA. But that did not last long. We got a lot of pushback from building owners, building operators. The pushback was mainly around the energy intensity of increasing outside air. And also it was infeasible to, for example, do 100% outside air and maintain comfort at the same time. And it wasn't really feasible in a short pandemic, time to, pay a lot of money to upgrade your ventilation system to allow for 100% outside air. And at the same time, we learned more about the virus, the particle size distribution, the mode of transmission, and more characteristic about the virus itself. So fast forward to January of 2021, the ASHRAE Epidemic Task Force issued what we call core recommendations. And these core recommendations are the basis of the detailed guidance of every single, building type. And they were written in a simplified manner. And the goal was to deploy one or more combination of ventilation, filtration, air cleaning to achieve your exposure reduction goals, while at the same time considering three things: comfort, energy cost, and first cost. So you're allowed to do that flexibly as long as you get to your goal of exposure reduction. At the same time, you need to define this goal, how much exposure reduction you need to get, and ASHRAE published a calculator in terms of equivalent clean air delivery rate. So we went from do a lot from everything, and some of the recommendations were contradictory, to basically, let's consider cost, let's consider energy cost and comfort, and combine air cleaning, filtration, in addition to ventilation. To put it into perspective, there is few studies out there that talk about the difference in energy cost between the different strategies. For example, upgrading filtration from MERV 7, which is basically low efficiency filter, to MERV 13, high efficiency filter, will cost on average 3 cents per square foot. To do the same thing, to arrive to the same exposure reduction in terms of ventilation, you need on average 50 cents per square foot. And you get to the same number. So you can see that, filtration is much more cost effective than ventilation.
All right. Well, that is a very valuable perspective. And both of you have lived through the evolution over the past couple of years. Now at a high level, you talked about the paper. Let's get into the framework itself that is advanced in the paper for sustainable IAQ. How can building owners and operators achieve this? Like, what is the concrete for people who are actually in the building and need to make decisions on what they're going to do? What is the framework that you're putting out in the paper?
Yeah, so I'll take a stab at that. The whole concept we've developed, we've decided to call it sustainable indoor air quality, to try to capture this notion that the goal really should be about delivering good indoor air quality, but doing it as efficiently as we can, efficiently from an energy standpoint, efficiently from a cost standpoint. That's what makes it sustainable. And, based on what Marwa just described, as we were watching the ASHRAE guidance evolve and listening to industry leaders, people like Bill Banfleet, describe the evolution from, at first, as Marwa said, precautionary principle, just pump in as much outside air as you can, sort of the ventilate first approach. It started to become more nuanced. And we started talking about layered strategies and equivalent air changes and the role that air cleaning and filtration could play. And so with that, we sort of captured that concept by developing what we're now calling a clean first framework or approach to achieve sustainable indoor air quality. And within the clean first framework, there's 4 steps. And I'll briefly summarize them, then we can talk about them in a little more detail. But the first step is to first define what we mean by good indoor air quality. So step 1 is define our indoor air quality goals. What do we mean by good indoor air quality? Step 2 then is to say, okay, let's see how many of these, how close to these goals we can get with air cleaning. Because as Marwa just illustrated, air cleaning is usually going to be more cost effective than just increasing ventilation rates. The third step, once we have air cleaning, is say, okay, how much additional ventilation do I need on top of air cleaning to make sure I'm achieving those IAQ objectives that we define in step 1 while maintaining building pressurization. And then the final and really important step is, okay, how do we validate that we actually achieved those goals with the design that we implemented? And how do we do that on a continuous basis? And ideally add a control layer so we can dynamically adjust and optimize as we go based on different conditions indoors and outdoors, different occupancy levels, these sort of things. So that's in a nutshell, 4 simple steps that people can follow in existing buildings and new buildings to first clean the air as much as we can to achieve a specific goals, then add the ventilation piece. So it's clean first rather than ventilate first. And that's how we achieve sustainable indoor air quality.
So just let's dive into those 4 steps. And I want to start with step 1, because at one level, what the clean first framework that you just outlined seems obvious. Set goals. The big kind of change in thinking that you're advocating is to look at cleaning first as opposed to ventilate. But the reality of even step 1, setting goals, is not something that is common. In our experience at Safe Traces, even some of the most advanced building owners and operators aren't even clear on step 1, what is our goal, and setting targets. And this is coming after 2+ years of the pandemic. Why do you think that even today it is not well established that people are setting IAQ goals out of the gate?
Yeah, it's not easy, defining indoor air quality goals. But the good news is that we've come a long way in the standard. So we have ASHRAE standard 62.1 now have a list of design compounds and PM 2.5 that you can adopt and design for. We also have ASHRAE standard 189.1, which is the standard for high performance green buildings, also provide a list of contaminants. You have LEED, different credits. There is a pilot credit for indoor air quality. There is an indoor air quality assessment. And there is, a lot of different green building certifications in the US and internationally that give you, specific, design compounds and their limit. Traditionally, we only focus on carbon dioxide and to lesser extent, PM 2.5 and TVOC, especially when you think about, monitoring these pollutants in buildings and making decisions based on them. But now we're learning a little bit, a different path. You need to have pollutants that are representative of outdoor generated pollutants that come inside through, infiltration or intentionally through mechanical ventilation. And then you have a representative of volatile organic compounds or, gas was generated indoors and they are abundant indoors. So in terms of outdoor generated pollutants, we have PM 2.5 and ozone. And if you look at the research today, PM 2.5 by far contribute the most to the burden of disease. And we talk about commercial buildings, but the same thing as well for residential buildings where you have, sources of cooking and unvented combustion. In terms of volatile organic compounds or representative of indoor generated pollutants, you have formaldehyde. Beside PM 2.5 and ozone, formaldehyde contribute the most to the burden of disease when you talk about the whole class of volatile organic compounds. The reason being is that, it's cancerogenic. It exists at levels in building that are relevant to the design limit and high emission rates. And usually if you do the calculation, it will be basically the contaminant that's driving the calculations. And then there is carbon monoxide. We always include it in all the standards, because it's really important, it's deadly, and it's important to commission to make sure there's no source generated indoors and outdoors. You can also add carbon dioxide. There's a whole scientific debate about carbon dioxide. We know that it's a very good representative only of ventilation, but it's not a good representative of indoor air quality when you are implementing, for example, sorbent filters or particulate filters. And in terms of carbon dioxide as a pollutant, we know that the number is less than 5,000 parts per million and likely more than 1,000. There's a new indication that it can be like maybe around 2,000 or 2,500 parts per million. So step one is to define indoor air quality goals in terms of the design compounds and the design limit. And then once you have this, you can explore the different steps.
So now moving forward to steps 2 and 3, which are clean first and then ventilate to the extent that you need to add to the cleaning impact. That's where enVerid's own technology is most directly relevant. So you mentioned in some of the previous responses just the kind of cost differential of ventilation versus filtration, which is helpful. But I would like you to elaborate a little bit more specifically with enVerid's own technology and other technologies beyond just cranking up the outdoor air or using different MERV rated filters in the air handling units. There's innovation happening in terms of how we actually filter. And I would be interested to hear both from a particle removal and reducing the contaminants in the air, so essentially efficacy, but then also the implications on that for both costs and energy efficiency. What are you seeing in terms of your technology being deployed in the field? Like what type of impact and efficiencies are you able to bring, and what are other new technologies able to bring relative to the traditional kind of approaches? Yeah.
Well, I think the key thing for people to understand when we think about air cleaning, building on what Marwa was saying in terms of the different types of contaminants, is that we need to make sure we have air cleaning in place to address the particles, the PM 2.5 that Marwa was talking about, which is a large contributor to the burden of disease in terms of outdoor air, but also deal with, of course, with COVID, there's a lot of concern about viruses and sort of airborne pathogens. This is where Safe Traces obviously spends a lot of time. Which is really small particles, right? Because the virus doesn't pass naked through the air, it attaches to a particle. So we talk about particles, we talk about pathogens, which are smaller particles, and then we talk about gases. And that's really where our focus at enVerid has been on technologies to capture gases from indoor air, remove them from indoor air using sorbent filters. So I think the first important point around step 2 is we need to layer these different technologies together. It's not one or the other, it's a layered approach. And that's really what the ASHRAE guidance during the pandemic highlighted, is these layered approaches. But in terms of your question on the economics, Marwa said it very well, I think. The analysis that we and others have done highlight that not in every climate zone, but in many climate zones where it's hot and humid this summer or cold in the winter, just relying on more outside air ventilation to deliver better indoor air quality is very energy intensive, because all that hot, humid air, that cold air needs to be conditioned. And when you look at a full building, HVAC is usually about a third of the load of a commercial building, and the ventilation portions anywhere between 5 to 15%, again, depending on the climate zone. So it's a meaningful portion of the overall energy, intensity of a building. So wherever we can use cost-effective, validated technologies to remove particles, pathogens, and gases, that's almost always going to be more energy efficient without compromising indoor air quality. It's just a different mechanism to capture these gases, remove them from the airstream or the particles of pathogens. So that's really what enVerid has pioneered from a gaseous contaminant side. But what we emphasize in the paper, it's a layered approach. We combine technologies for particles, pathogens, and gases. And then the other important point is, and we tailor that for the climate zone, right? So we get a cost-effective result. It's not one size fits all, in every market in the country. But the other important point is to talk about step 3 a little bit. We're not eliminating outside air entirely, right? Because we still need to maintain building pressure. And we may want some outside air for other reasons as well. And so it's again, just like it's layering different air clean technologies and optimizing for the climate zone, it's also about optimizing the ventilation rate in order to get achieve the targets we set in step 1, but do it as efficiently as we can without compromising into air quality. And there's some great work ASHRAE has done. Marwa can maybe elaborate this around these different ways to determine the ventilation rate that accounts for the air cleaning technologies that can be deployed to address the particles, the pathogens, and the gases.
Yeah, so you have basically the prescriptive approach, which is one of the methods to determine how much outside air you need through mechanical ventilation. And this is based on the concept, solution to pollution is dilution. But you don't consider, the quality of outside air. You don't consider unusual sources and you don't consider source control or source removal. So it's one size fits all. The second approach, which really has been in the standard since a long time, it's called the performance-based procedure, indoor air quality procedure. It's very flexible. You can consider ventilation, but also source control and source removal. Source removal, as Christian mentioned, you talk about gaseous removal and also particulate removal. And more recently, we start talking about, pathogens. The nice thing about this method, you can be specific to your project. So the building type, your project location, which climate you're in, the quality of the outside air, and figure out a method that works for you to achieve, what you desire in terms of indoor air quality goals we talked about a little bit before, and also your energy goals and, carbon emissions. To give you another, sound bite about the cost, dollar per square foot, let's say that the baseline is only outside air. So Christian talked about this, ventilate first. And this outside air is to get you to an equivalent air quality, MERV 13, and all the gas with pollutant limits in ASHRAE standard 62.1. So this is a baseline. If you employ this indoor air quality procedure with MERV 13 and sorbent filters, you save approximately 77 cents per square foot. If you add on top of it energy recovery to recover, some of the indoor air conditioning energy that you put in with the outside air coming, you save 81 cents per square foot. So what we talk about here in the indoor air quality procedure, sorbent filters, MERV 13 filters, and energy recovery, you have 81 cents per square foot energy savings compared to the baseline. Both will get you to the same goal, which is a specific, exposure reduction from pathogens, particulate gas, but you can see the big difference in energy intensity between those two methods.
Yeah, that's a huge number. That's a needle moving number, 81 cents per square foot. So I just want to underscore that. So moving on, just to round up the 4 steps. Step 1 is setting goals, and then step 4 is really important in that it is promoting validation, monitoring, and controlling indoor air quality. And that's critical not only for the building owner and operator, but it's also for companies like enVerid and others who are providing air cleaning solutions to be able to show that their approaches are actually working and be able to put numbers around that. Can you talk a little bit about, from your perspective, why step 4 is critical to kind of unlocking the whole value of the Clean First framework?
Yeah, the challenge with indoor air quality, and a little bit in response to your question about step 1, why aren't more people setting goals, is indoor air quality is somewhat complex. And in the paper, we try to simplify it. And as Marwa nicely outlined, give you just a few metrics to focus on. That distills down what the ASHRAE guidance and the scientists point to. But the other challenge is it's complex and you can't, it's invisible, right? Indoor air quality, you can sense it sometimes. You go into a room that's stuffy or there's smells perhaps, and then you experience it. But a lot of these things like carbon monoxide literally are, invisible. And so that last step is really important because we want people, when they're going to make the adjustments that Marwa described to save all that money, to trust, to know not to trust, to verify that they're saving all this energy without compromising indoor air quality. Because there's this sense, that dilution is the solution to pollution sort of concept. People become very comfortable with that. But if we're going to start reducing outside air and improving air cleaning, like they want to know it works. So the step 4 is really important. And we sort of break step 4 into 3 sub-steps, which is first, once a design is implemented, or there's been a change in the building, a modification, or there's been a pandemic, we want to make sure everything's in order. We need to go in and do point-in-time testing. And you guys have pioneered this in terms of the aerosol tracers for the pathogens. We can go in and do testing with handheld sensors and other air sampling techniques for the gases and for particulate matter. And that's really important to make sure that on day one, the design that's implemented is actually, working in reality. But then what we want to add to that is continuous monitoring for those contaminants where there are valid technologies available, proven, technologies to track different sensors. Some of the metrics Marwa mentioned can be measured on a continuous basis today. Others, you do need to go in periodically and do air sampling. So we recommend a combination of the two. So it's both. It's the field validation plus continuous monitoring where that's available to provide that validation, give the assurance to the owner, give the assurance to the tenants, that the air quality is good, even if it's being achieved in a different way, even if it's more efficient, which of course is a good thing. The assurance is really important. But the last piece in that 3rd step is the control optimization, because buildings are not static. Occupancy rates change. Outdoor air quality changes in times of the year, days of the time of the day, and things happen indoors, which affect indoor air quality. So the important part in step 4 is to tie the air quality monitoring you're deploying into the control system so that you have the ability, or better yet, it's automated to adapt outside air volumes, air cleaning, sort of how many systems are running at one time, for example, and make those adjustments. And that gives you then the assurance that, yes, we achieved the goals in step 1 through this clean first approach, and we're showing that we didn't compromise anything along the way in terms of those air quality goals.
So let's move to the business case here. In some of the stats and the dollar per square foot numbers, you hit on this, but let's take a little bit of a broader view. So if you're a building owner or operator right now who may be listening to this and skeptical and needs some convincing on this is something they really need to do, what is your case to them? Thinking about the financial benefits, but also some of the market drivers that are happening, some of the policy regulatory standards drivers. Why should someone not just kind of punt on this or keep doing what they're doing? Why is this something that they should be doing and doing now or sooner rather than later?
Yeah, I can start with the retrofit business case and give you an example about a project we did at University of Miami. It was basically a health center. So it was a little bit complex space because you had a gym, you had like a wellness center, you had offices, and you had cafeteria. So it was, and they had a pool as well. So it's, a multi-use space. And when we did the walkthrough in the building, it was apparent that the building was underventilated. But the reason was why they didn't, use outside air is because they could not keep up with the humidity. You have people exercising inside, it was a humid environment inside, and it being in Miami, hot and humid outside. So they suffer with humidity. And because comfort is something you can measure easily and feel, they reverted to close the outside air and just having recirculation. But they had a need to improve indoor air quality. So depending on outside air was not an option because of implication on comfort, and also upgrading the system to get more outside air was, cost prohibitive. So they tried this approach, the clean first approach. They had particulate filters, but really they were not keen on the replacement schedule, on making sure there's no holes in the filters, like bypass. So they focused more on this. And in addition to particulate filter, they also implemented sorbent filters. And we did the calculation based on the indoor air quality procedure. So we put, defined indoor air quality goals, define, the pollutants that we want to measure, we want to design for, their limit. And then we, specified specific, particulate filters and quantity of sorbent filtration. Result in that, we did measure energy impact, and as you expect, we had a big impact in terms of energy savings because we were able to decrease outside air, large volume, I think 75% decrease. And we optimize it in a way that we decrease it until we had no longer problem in humidity. So you still have a chunk of outside air, but it will not impact comfort, specifically in terms of humidity. And with the help of the sorbent filters and particulate filters, you still met the indoor air quality goals, basically based on ASHRAE standard 62.1. So resulting was energy savings, maintaining comfort, specifically in humidity, and you saw improvement in indoor air quality, specifically in formaldehyde levels. So this is a very compelling business case. If you want to simplify it, is they were able to be compliant to building code, to ASHRAE standards, at the same time improving indoor air quality. So these are, two major milestones. And I have to say something before I hand it to Christian. Even before the pandemic, we noticed that, most buildings operated with no outside air. And I'm not talking to you about, Class B or Class C, Class A office buildings. And we wrote an article about the 6 reasons why they do that. But number one that always come in is basically energy savings. With the pandemic, they also need indoor air quality. And this is a main business case for this Clean First framework.
Yeah, the case study that Marwa just described in Miami is a great one. And what I can add to what Marwa just described in that project is that it also saved the money because we were reducing the need to condition outside air. And so I think it was $30,000 a year or so in energy cost savings that gave it an attractive payback. That's a great example of a retrofit. I can say we've got many examples where different parts of the Clean First framework have been implemented and delivered similar results in sort of retrofit applications. But what's exciting is that in new building applications or in applications where we're replacing older HVAC systems with new systems, the economics become even more attractive because in these new buildings, you have to design these new mechanical systems to the code. And when you can apply the IAQ procedure portion of the code in the context of a Clean First approach, where you have the different air cleaning technologies, the sorbent filters for the gases in particular, you can actually oftentimes go from an 80-ton system to a 50-ton system and save money right away. So the Miami example had a nice payback over a number of years, but many cases when Clean First is implemented in a new construction context, you not only do you have those ongoing energy savings, but you're saving money on day one because you're downsizing these systems. Or that money can be used to pay for other technologies that otherwise might be viewed as unaffordable, like putting in IAQ monitoring or a smarter building management system that's going to be able to better control how the building runs to achieve IAQ energy efficiently. So I think that, we've got great examples. Happy to share more examples. There's one in the paper. In fact, the one Marwa described is in the paper. So if people want to take a deeper dive, they should have a look at the paper and read the case study. And what we hope happens is that the paper encourages more people to explore this Clean First approach and work with us and the other companies that participated to develop more case studies. We want to go demonstrate this in the field. We've started that process, but we see much more opportunity and hope to have many more case studies to talk about next time we're on the show with you and invite people to join us and help build those.
Mm-hmm. Great. So as of the time of this recording, which is in late August, the paper has been released for a few weeks. I'm interested to hear candidly the feedback that you've got from thought leaders, practitioners, so folks within the engineering and building services world, and then other stakeholders in terms of what you're proposing here. Has it been supportive, interested in wanting to learn more? Has it been resistant, indifferent? What's been, I'm sure there's been a spectrum, but what's been the feedback so far?
Yeah, maybe I'll share a few things. Marwa, go ahead, Marwa. You have something on your tip of your tongue.
I want to say, so if we had the paper out beginning of 2021, I would tell you it would have been out of taste. But now we went through the motion of the pandemic and how we can do both, save energy at the same time, not compromise on indoor air quality, and even more improve it. We got very good feedback. I personally got very good feedback is that, finally we can, put this notion front and center, saving energy at the same time, improving indoor air quality, and talking about cost, it's okay. and employing some innovative technologies and processes like we're doing today with the different collaboration of the different company. So I'm definitely in the camp that the feedback that we received was very encouraging, and to keep getting this framework and keep improving it and see what impact we can make in the standard world as well.
Yeah, I was going to echo that by saying that there was somebody that many of you probably know in the industry who early on I had approached about this notion of a clean first approach. And the response was somewhat hesitant, or someone like, oh, that sounds very bold. But as we got through the pandemic and the guidance evolved and we got smarter about different ways to achieve indoor air quality efficiently, that same individual and many others have really said, no, this is the right time for this. We need this approach. And in fact, we need it because even if, we can debate more ventilation, less ventilation, indoor air quality, but when the outdoor air isn't fresh because we've got wildfires or things like that happening, we don't really have other options than to clean the indoor air first. So I think the timing is very good. The one other anecdote I'll share that sort of underscores how quickly the industry is evolving and embracing approaches like this is there were some people I talked to early in the pandemic, again, about indoor air quality monitoring. And they said, no, I don't want to know. That becomes a risk. If I know that there's a problem, then I'm liable and I'm going to have to deal with that. Talk to the same people literally 6 months later in the pandemic, and they say, no, we need it now. Because actually the risk is not knowing what's going on, because people are demanding that I know and I have a handle on it. So the pandemic has accelerated lots of things. That's perhaps the silver lining here. Indoor air quality is much more on the agenda. People are thinking about it. They want to know what it is. They're viewing it more as an opportunity than a risk, or at least something that they need to address. And especially with the pressures with outdoor air quality, we need clean first approaches. And that's the reception that we've gotten with this paper, which has been great.
And that's been our experience as well, is that in general, the industry often is perceived to move slowly, and it does. Industry is in real estate, and then folks with equities in real estate. But I certainly can attest to things are moving now. Sometimes it's subtle, sometimes it's not consistent everywhere, but there's certainly change afoot, very much in line with kind of the approach that you're promoting, which is great to see. Just to close out here, so the paper has been released. There's been a press release and announcement on that. What's next? Where are you going with this and with the other folks involved for the rest of this year and beyond? And specifically for folks, whether you're a building owner and operator and you're interested in this approach and how to implement it, that's one natural kind of audience here for this. And it's like, this is great. What do I do now? And then also for other companies that are involved in the kind of air cleaning space, how, is there space for them to get involved in this? And if so, how?
Well, first, I'd like to say if we've interested you in this topic, please take some time to check out the full white paper, which is available at whitepaper.enverid.com/sustainable IAQ. So we hope you'll take a look at it, and we'd love your feedback, because we consider it a living framework that will continue to evolve based on the feedback from the industry. I can say in terms of next steps, we're now working on a continuing education course around the framework. So you can read the paper. You can also take the course and get some of those continuing education credits you might need before the end of the year. We'll be out on the conference circuit talking more about this, just like we are on this podcast, and looking to develop case studies. So have a look at it and reach out to enVerid or the other collaborators, or better yet, reach out to Marwa, who as a consultant in the industry can really help you think about how to put all the pieces together without necessarily working directly with a specific vendor, if that's more comfortable. And maybe Marwa, I'll let you speak a little more how you can work with organizations to put all these pieces together in an advisory capacity.
Yeah. And, our focus, or my focus, is about the modeling part of things and the sort of the calculation and how to get from the defining indoor air quality goals to prescribing and optimize a ventilation system with energy recovery and doing the indoor air quality procedure. So we are implementing those in a new ASHRAE course. So please be on the look to check this out. And hopefully we'll have a calculator with that open source calculator where you can implement many different technologies and just play with it. It's performance-based approach. The nice thing about it is that you can play with it, different scenarios, and see what works for your project.
Excellent. Well, thank you both so much. Congratulations again on getting this out there and all the hard work and years of research and things that have led to this. And good luck. And we look forward to, speaking from my Safe Traces hat. We're really excited about this, and it has a huge potential. So thank you for everything you've done. Thanks for coming on today.
Thank you. Thank you, Erik. Thank you, Christian.
Thanks for all your support.